Good morning, good afternoon, or good evening, wherever you may happen to be, and whether you're watching live or archived. And welcome to part 3 of a series of collaborative webinars between Nautel and our friends at the Telos Alliance. I'm your host, Jeff Welton. I'll be with you today along with a cast of characters. Before we begin, I want to show you a few housekeeping things we need to deal with. As always, our webinars do qualify for half of a recertification credit under Category I. If you're an SPE member, don't forget to jot that down. If you've got any questions, we will look at them throughout the webinar, and I'll insert them wherever we can, depending on time and where it fits. But certainly feel free to throw your questions into the questions screen just by clicking the little button that you see on your page. Now, let's move right ahead. We've got a lot of stuff to cover, and it's going to be a whole lot of fun. We've got a stellar cast of guests and friends today. It's just awesome. Number one, a good friend, Rick Greenhut, who's an independent media consultant. And Rick, welcome aboard. Glad to have you with us.
Thank you.
We've got Marty Sachs, the Executive VP of Sales Support and Marketing for the Telos Alliance. Marty, welcome aboard.
Hey, thanks. Good to be here, Jeff.
And from the Nautel side of things, we've got our Chief Technology Officer, Mr. Philip Schmidt.
Hello.
And last but not least, Mad Scientist Extraordinaire, also a Nautel support tech, we've got Alex Hartman.
Hi, guys.
Good to see you all aboard. So what are we going to cover today? Well, we have got a bunch of things to deal with. So Philip, if you want to move us ahead, thank you very much. We're going to talk a little bit about the collaboration and the virtualization. If you watched our last couple of webinars, you saw where we dealt with quite a bit of things we were working together with the Telos Alliance on, and some things that we've done that really can be pretty intriguing for those of us doing any kind of HD stuff at all, and you know, just HD radio or any kind of content delivery at all. Marty, maybe you could address one or two of these things as well. If we can just flick ahead, I think, Phil, to the next slide. So why this collaboration? What brought this on?
So, Philip, you want to take that first? Or you want me to?
Sure. I mean, one of the big parts of our collaboration here is, you know, Nautel, we're certainly the experts in the transmission side and, you know, dealing anything with keeping your signal on air 24/7. But the collaboration with Telos, also very innovative and forward-looking company, that's more on the other side. Bringing those two together, we can really build a whole air chain, and I think that is really what we're able to bring to the table together here.
Absolutely. I couldn't have said it better. I think the thing that is very exciting for us at Telos is our longstanding friendship with Nautel. We've learned so much from you guys, and we're very happy to talk about the future. And so this is the culmination of a lot of our work behind the scenes. So very exciting time.
Well, thanks very much for that, guys. And we're going to lead it right off and get moving. So as I mentioned, Rick Greenhut, I've known you for many years, going back to, I think, before your Xperi days even. But you're going to tell us a little bit about the technology behind this. So go ahead.
Happy to. I kind of want to give you the 50,000-foot view because digital radio matters now more than ever, and there's a couple of reasons for that. Number one is, in the US alone, there are over 65 million HD radio-equipped cars on the road. So this has gone from a science project to being a mainstream technology. There are a lot of opportunities to monetize, and that becomes a webinar in and of itself. But the fact that streams that you may already be creating at your radio station might be perfect fodder for an HD channel. The fact that there are podcasts, you already have your air talent involved in doing things on the web. You may already have 2/3 of a channel already being built. There's a huge opportunity for leasing channels, especially to foreign language institutions or religious institutions in your market, folks who can't afford a radio station, but could afford to lease a channel from you. And of course, sports coverage. all over Texas, where, as people well know, football is more than just a sport, it's practically a religion. And the ability to take high school football and high school sports and put it on a separate channel and have the local university or the local high school do their own play-by-play is a fabulous opportunity to both give back to the community and, not incidentally, generate new revenue. There's over 2,300 HD radio stations in North America, but there's still over 13,000 analog-only stations. And there's a lot of reasons for that, many of which were absolutely accurate 10 years ago or even 5 years ago. But things have changed. It used to be too complex. It admittedly used to be very expensive, and there wasn't a clear path to ROI. But right now, there are cheaper, easier, and more flexible on-air chain solutions than ever before. If we take a look at the next slide, about 23%, almost 1 in 4 of all the cars in the road in America already have an HD radio receiver. What that means is consumers, your radio station's listeners, have already gotten used to having all their in-cabin entertainment sources offering images and metadata. That is, except for analog radio, the only medium that is in touch with consumers that isn't already 100% digital. So remember that old commercial about this is your brains on drugs? Well, this is your station in analog, nothing but a frequency. But this is your station in digital. Here's an all-news station, happens to be in Washington, D.C., also happens to be the top billing radio station in America. And the ability to show that kind of information on the screen, or their HD2 channel, which is a great example of localized programming. For years, they had already reached out to federal workers. In Washington, which is a company town, the company happens to be the US government. With hundreds of thousands of federal workers, the ability to have a radio station just for them on an HD2 channel is the ability to both serve your community and make money. And their HD3 channel, well, that's music. And it's music that literally runs the gamut, which is why that's what they call the format. They're filling a need that no other radio station in the market does with that particular mix of music. If you take a look at the next slide, you'll see that a lot of the new radios will also take that metadata and image information that HD radio allows you to send and make it your preset buttons. So rather than just having the call letters or the frequency or just a number on the button, your logo can be there. And here's why that's important. Your satellite competition has been doing this for years. Don't forget that everything else started out digital, unlike radio. And for that reason, images and metadata were baked in. So this is what you're competing with. If you look at our next slide, you remember that radio now shares the dash with a myriad of competitors that didn't even exist 10 years ago. Whether it's iPod or audio apps, if you look at the next slide, you'll see there's things to worry about you never had to worry about before, like Apple CarPlay and Android Auto, both of which relegate broadcast radio to some submenu below a menu below another menu. There are competitors that didn't exist before, things like radio.com, things that are line extensions for existing radio companies like NPR One, Amazon Music, iHeartRadio. They're all out there and they're all available on the same level as your radio station. So here's what it comes down to. The moral of the story is very simple. With all the media choices that are now available to the consumer inside that car, radio's digital metadata and images, as delivered by HD radio, can help level the playing field. The bottom line, the message is very simple. Don't be the blank screen. There's no more radio button. The button on that radio now says audio. And while sure, AM and FM are still there, But right there on the same menu is Sirius XM, Bluetooth, USB, all the things that exist on the screen along with radio. So everything you're going to hear in the rest of this presentation all goes towards making HD radio easier to implement, less expensive, and ultimately to get that hardware and software out of your station and up into the cloud where it's virtualized. Let's look at the digital broadcasting upgrade cost in perspective. Back in the day, for those of you who remember, the equivalent amount of money that it used to cost to take your FM mono station and make it stereo is about what it costs today to implement HD radio technology. And the reason people did that without a clear return on investment was the expectation would be that higher quality audio would keep existing listeners for longer periods of time. And that increased TSL actually did come to pass. So what occurred? Stereo quickly became what we all learned in Las Vegas at the NAB is table stakes. It became the cost of entry that all FM music broadcasters needed to remain competitive with their marketplace. By the end of the century, it was a must for FM music stations. Digital broadcasting has rapidly become the 21st century equivalent of FM stereo. Nautel is going to show you some new and innovative ways to achieve that.
Thanks very much for that, Rick. I do have to put the little side note in that you mentioned that the FM stereo costs related to 1965. I don't remember that. That's the year I was born. But yeah.
Well, thanks for rubbing that in.
I couldn't resist. So on the topic of bringing costs down and trying to bring reliability up and just improving performance overall, I wanted to bring Marty in. And Marty, before we get started, Rick made a comment about the 50,000 foot view. And if I'm not mistaken, you spend a fair bit of time at altitude, don't you? You're a pilot or flight instructor.
Yes, that is correct, but nowhere near 50,000 feet. So the maximum for guys like me is about 10. So yeah.
That's still a lot higher than I get most days. So on the virtualization aspect, what are we looking at? Where are we going with this?
So I think the thing that's pretty interesting is to sort of look at where we're at today, and that is this idea that we have this amazing technology available to us, known as virtualization, and this stuff called the cloud, and it's hard to look anywhere nowadays and not see IT technology, right? And essentially not see IP packets. Basically, everything's been packetized. And to Rick's point, our analog FM and AM are pretty much the lone folks standing in the analog world these days. And obviously, we want to change that. So IT is, of course, the source of many of our standards, including the increasing focus on network security. So IT is very much a part of what we think the future broadcast environment is going to look like, and of virtualization, of course, being a big part of that. The industry has really morphed over these past number of years. We very much were, an industry built on purpose-driven, purpose-built hardware. Okay, one box that did this, one box that did that, all connected together, by typically, single or two pair wires. Or multi-pairs if you were really, high tech. So, we've seen this change in the industry from these purpose-built boxes to more and more hardware that's essentially based on x86 motherboards. So, we're taking what the IT industry makes available, for commercial use and applying that towards, different problems to solve in the broadcast environment. And the key here is, why IT? Well, the reason IT is so important is because there's the scale of an industry that the broadcast technology industry could never come close to. So think about, if you have a percentage of overall revenue of an industry that is spent on R&D, 20% of billions or hundreds of billions is a lot more than 20% of hundreds of millions. So you have these huge companies, people like Cisco, who are driving the state of the art forward very, very quickly. They have huge design teams, and we can take advantage of their R&D to do much of the the heavy lifting in our world. The other thing that's pretty interesting is this idea of virtualization, versus physical equipment, allows us a much higher level of customization and flexibility. So I don't need to tell anybody on this webinar, and especially not you, Jeff, having traveled to so many stations as you have over the years, is everybody has a different workflow. No two stations are alike. Even inside the same company, there can be just widely ranging differences in the way audio and data flow around a broadcast facility. So again, not telling you anything you don't know, but the idea of virtualizing and using cloud allows you to have much higher levels of control over what those workflows look like. And ultimately, it's all about the audience. How are we going to tailor these particular pieces of content or shows, or however you want to describe your audio? How are we going to tailor those offerings, to that bigger, larger audience? And so, your friends at Telos and Nautel, we've been working hard. We're of the strong belief that there will be even more customization as we go forward with workflows. And I can imagine, our companies can imagine this idea of having lots of formats that are temporary. Maybe only during the holidays, certain formats are on the air. The idea of being able to spin up and spin down instances and channels, or change what's on those channels very, very quickly. We have a contribution specifically to the Nautel, platform here that we're talking about today, and that is this product we call the Omnia Enterprise 9S. Here's a screenshot. Basically, what this is a virtualized version of the Omnia 9 processor, and we have different versions and variations of this product. But essentially, think of this as running in the virtual environment and not a hardware box, bolted into the rack. Lots of capabilities in this product. It's a world-leading product in its box form, but we have several instances now of very large enterprises running hundreds of channels in the virtual environment through Omnia 9 processing. So, so that's the idea of our contribution here, is to make world-class processing available, in this environment. And next slide, if you would. The idea here is really to think about the future. And Rick hit this pretty heavily. Where are we going to be, to be able to compete with all the other offerings that people that are fighting for the share of our listeners' ears. So we want to make sure that we create something, and we've worked very hard to do that. That will adapt over time. That's a big issue that we've faced in broadcasting, is some of our standards have been very closed and very tight, and when the world has changed, we haven't changed as quickly. So we're focused on this idea of overcoming the pain that comes from an OS change, okay? And that sort of breakage that occurs. We've all been through it, right? What do they call it? Patch Tuesday? We've seen the changes to the standards. RDS is one that's changed quite a lot over the years. In the virtual world, we can streamline the systems. We can adapt to change more quickly. We can make upgrades in one place, not 100. It's a very interesting capability that comes and a very future-friendly capability. And finally, just to talk sort of at the end here, is that these are the sort of the big three. All of us that are on this webinar think about these topics. That's why you buy a Nautel transmitter, right? You want a reliable rig. So our thinking here is that when you scale down the amount of dedicated broadcast hardware in a facility, you reduce a lot of the potential for failure. When you put it all instantiated up in the cloud, all the cloud services have very high levels of reliability and lots of fallback opportunities that can all be pre-engineered into the system. We don't have to worry about our phone ringing in the middle of the night to deal with something. It's really reducing the hassle factor. It also has the side benefit of much lower install costs, much less wiring and purpose-built, sending crews around the country to update something or install something new. and there's a very high level of remote management that's capable when you are, virtualized. So there's a lot to like here, and we could spend the next couple of hours talking about this topic, but my time's up. So Jeff, I'll throw it back to you.
Well, thanks very much, Marty. And I mean, one of the things I think that my key takeaway from this so far has been flexibility. And I got one comment that that mentions that it does potentially increase the risk of total failure. But again, it comes back to flexibility. Historically, our system was limited by where the wires took us. We could send the data from over here to over there where they were connected. And we're pretty much eliminating that restriction. So it does give a whole lot more options. And I want to have Philip address some of that as well.
Jeff and Marty, very good summary of why we're looking at the cloud, and hopefully with some of these practical examples we're going to show you today, it will drive home some of these points and address some of the concerns you may have. But before we can get really into the meat of our discussion, we need to do a brief recap of webinar 2 and a little bit of webinar 1. And certainly if you want to look at more detail, review those webinars. We'll go pretty quick. But one of the challenges from moving into the cloud and at the level that we're talking about is to deal with the synchronization issues that exist in the current broadcast system. So that is sort of a stepping stone to get into virtualization and really to achieve what we call location agnostic systems. So we'll do a really quick recap of the last webinar, and we'll, for any more details, certainly consult those. On the next slide. There we go. Yeah, we've already talked about the complexity that HD radio has brought about, that also Rick mentioned earlier. And reaching back to some of the early days, it required separate STLs, sometimes a second transmitter for the HD for high-low combined systems. It required the equipment to be back at the studio, and to manage all that was challenging. And one of the problems that arose fairly quickly was how do we keep the throughput delay of the FM and HD to within the tight tolerances that exist in the system of 3 audio samples, 68 microseconds. That is micro and not milliseconds. It is a very, very tight window to hit. We'll get into that in a little bit. So the next slide here shows you why we need such a tight tolerance. When the receiver blends from playing the FM and then locks into the HD, there's a brief period where it's blending and plays both audio streams simultaneously as it rolls down one and brings up the other. And that creates an audio filtering effect. It can create audible artifacts if it's not set up correctly. So in the top slide here, if you align within the specification, then it may affect your high frequency audio a little bit. But it's typically not very noticeable. So if you're within the 3 audio sample specification, you're certainly fine. But as you get further away in delay, then what can happen is that the filtering effects can affect your main audio content in the 1, 2, 3, 4 kilohertz range, depending on how far out you are. But the other interesting effect that happens here is these comb filtering effects become much more selective, much more narrow as the delay gets out further. So yes, there's more filtering happening, but it gets more and more specific to specific frequencies. And it's highly unlikely that your audio content would hit exactly that frequency. So the interesting thing is that while the 3 sample specification is the bullseye, that's the best place to be, the danger zone is right outside that, and it gets a little bit better as you get further out. But our goal here really is, well, we're going for the bullseye. We want to get perfect time alignment and as best as possible, and that's what we're talking about today. So as part of the work in the NRSC, here's a couple of reference shots of typical diversity delay variations measured in the field with and without 10 megahertz synchronization here. But in both cases, it's very challenging to stay within the bullseye in today's architecture. It's possible, but if you follow all the guidelines that were established with NRC 5 G203 guideline, and that is certainly a very worthwhile read. It's it is very comprehensive, talking about many installation topics, equipment challenges, recommendations. That recommendation covers a lot of the issues that exist in today's generation of equipment. And it, if setting apart what the future-looking aspects we're bringing to the table here, this is still, you should abide to all the recommendations as much as possible in here. And with that, you can maintain consistent diversity delay, but there's still challenges. And one of the big things here is with the recommendation is to keep most of the equipment at the site. So that complicates site setup and installation and maintenance. So that's sort of the problem that we're trying to address here. So the solution that we work together with the Telos Alliance with here is essentially a concept I like to call, we're synchronous from split to join. And the audio is ideally split in a dual FM HD audio processor. So you have a single studio feed that feeds into the audio processor, and within it, it should be split into the FM and HD. And much of the initial processing should be the same between the two, so that when the audio blends, we have a seamless transition from FM and HD. But then at some point, the audio processor needs to do composite MPX processing that's specific to the FM, and it will do that. So we evaluated the Omnia Enterprise 9S and found that, for one thing, we were able to synchronize it with our own time base. That's why I've drawn in this timekeeper box in there. So that's one big thing, and it's operating on precisely the sample rates that we need. The HD system is built on 44.1 kilohertz audio samples. It so happens that we can configure the Omnia Enterprise 9S to run that. And the composite MPX is exactly 4 times that. So that made it very easy for us to come up with a synchronous system that, and that's what Nautel brings to the table, is sort of the glue between all of that, that allows us to come up with a new transmission protocol that we're proposing for standardization that combines both the composite MPX and E2X in a single pipe. Then in that way, we're able to eliminate time of flight, and we have a very cool demo that will show that in a little bit. It is suitable for feeding a new exciter design, which we also demonstrate here, that does both the HD modulation and the FM modulation, all in the same clock domain, the same sample rates, synchronously, so that there's no sample split between any of those. There's no ASRCs, asynchronous sample rate converters. There's no analog audio involved here. It's all in a digital domain. And we handle it with a synchronous audio processor and HD, a synchronous transmission protocol, and a synchronous exciter. So it is a 3-part solution. So the best thing would be just to show you what we're talking about here. So last webinar, we've shown you this system running on Alex Hartman's HD multicast in St. Cloud, Minnesota. And this data stream that I talked about, we delivered despite all warnings from Jeff Welton over the public internet. You completely ignored him here, but we wanted to stress test the system and wanted to show how well it could work. So we were running across the public internet, feeding VSHD transmitter in our lab. It produces about 80 watts of output, and we've hooked up 2 receivers to it. A Sophia streaming receiver by Innovonics that allows us to listen to HD 1, 2, 3, and 4s, check the station logos, all the graphical content that Rick talked about earlier. This receiver does a great job bringing that to you and allows you to monitor that. The other product that Innovonics brings to the table is the Justin 808 that allows us to measure the time alignment between the FM and the HD. So we have that transmitter feeding both those receivers live in our lab, and that was 2 weeks ago. So our demonstration today, well, it doesn't look that much different. It's pretty much exactly the same demonstration. However, we've managed to move the software-only solution that we provided on the HD multicast that has no more hardware requirements like specific audio cards, like GPS synchronization, we moved that right into Amazon Web Services. And in this case, we've hosted it in Ohio, still the same transmitter system in a lab here. It's agnostic as to what is feeding it, whether it's the cloud or the physical HT multicast. And the other thing that we've done, we've shuffled up some of the audio inputs a little bit, because now we're in the cloud. So we've added some web streams. We've connected with a radio jar account, which is an online playout system designed for streaming. But we're able to connect that as a proof point only for a complete air chain in the cloud to our system here. But best thing would be if we just bring up the system live. So I will start bringing that up here. So here we're looking at our transmitter, and I'll just do an abbreviated demonstration from last week. If you want to see more, certainly again, webinar number 2 has that. So we're running FMHD minus 10 dB injection at 80 watt combined output power, and it's just running along here. So the important thing now is let's have a look at our data services here. You can see we've put a little bit of RDS and PSD data in here. Had a little fun with that, of course. But you can see we named it Cloudporter as an importer-exporter in the cloud. And this is the first of the systems, and Alex Hartman will talk more about some of the other ones in here. We've hooked up some of the RS Experience station logo. And on HD2, that is the air chain that we connected with Radio Jar, and it just connects over a normal streaming connection, but we're able to process that in our Omnia 9 and add it in the side channel. So more importantly, the point of our demonstration here is the time alignment. So we've got our Justin 808 here again, and it's presently, you can see it's right aligned on the time alignment here. And we've got a 10-minute view here. I will zoom in a little bit more for our next demo, just so we can see it a little bit better. So we're looking at 60 seconds now. The other part of it is here is the control interface to the Omnia 9 audio processor. You can see it's producing the composite MPX in the spectrum above, with left plus right, pilot left minus right, and the RDS in here. That's what you saw coming up on the Sophia receiver. So that's all running on that same cloud instance, the same virtual machine that is now running on AWS. So all of that is sourced here. And to show you that we can affect that, again, it's very similar to the last demonstration. We've got about the exact same output delay from last time. If I now click on a single sample increase, 1, 2, 3, 4, 5, let's walk 5 samples off, kind of see that the instantaneous measurement of the yellow line in the Justin is ticking up. And it very nicely indicates now we're out of specification with a red warning flag. So let's dial it back in to be back to 0. 1, 2, 3, 4, 5. And it shows you now that we have it fully running in the cloud. We were unable to hook up a GPS to the cloud instance. We're looking at software-based synchronization, but both the transmitter and the cloud instance do not require GPS synchronization to maintain this time alignment. Certainly, there's many benefits to maintaining your GPS, but it is not required for the purpose of time alignment. There's other good reasons, carrier frequency stability, and other good reasons why you want to do that, but not necessarily for this specific purpose. So returning back to our demonstration, our presentation, I should say. Yeah, we've seen a lot of these parts here. Yeah, returning back to what our demonstration was all about, I'll pass it over to, one more thing I did want to show before I forget. This is the Amazon Web Services control that shows you this is our system that's running in the cloud, and it is currently set to US East 2B. uses about 50% CPU, and it's all running in AWS. And if you're wondering why we have two systems here, well, that's what Alex Hartman is going to be talking about next.
All right, thanks, Phil. So we decided with our last webinar that, we have the hardware, we've proven the point. Now, what happens when we remove the hardware? Something I'm pretty good at is taking away the things, so I keep making him stop going boom as Jeff's drinking his cup of coffee and coming out of his nose. But, if you remove the thing that goes boom, it doesn't really have the chance to go boom. So we evaluated this with virtualization in a cloud environment. Cloud environments are determined based on, it's not necessarily a rack of other computers, so to speak. That doesn't define a cloud. It's a pile of services and suites that you can utilize on these platforms, such as load balancing and fault tolerance, and completely transparent to the end user side. You have the hardware is their problem, not yours. So you don't see that part because you shouldn't concern yourself with that. So with that, they have a global presence to try and get closer to the edge of the customer. With these data centers and groups of data centers, they call them availability zones. So you can place them anywhere, and they're all clustered together. And again, in the background, they move themselves if something goes wrong, whether it be the great power outages of the East Coast or the wildfires in the West Coast. They can migrate the entire system to other areas around the country, if not the world. As such, you can easily, from your perspective, replicate these machines so you can scale these systems. So you have one working system, and say you're going to turn on a backup transmitter across town. Well, all it is right-click, copy, instance, run. Change an IP address, and you're done. So that really speaks to the volumes of how you can scale these systems extremely simply. So here we'll show you that we did exactly that. We took our hardware, cloned it once, and then did it 3 more times and moved it around just to see what would happen. So with this demonstration, we still have our original setup in the factory with our original multicast feeding our transmitter, but we've added these 4 Cloudporters just out in the ether, as it were, to determine what our fault tolerance will be. So if we go to the next one, I'll explain a little bit more about the top 2, which is running in what's called an AWS load balancer. So Amazon offers a service called load balancing and fault tolerance high availability. So you take a pool of resources above you, which are Cloudporter 1 and Cloudporter 2 are our resource pools, and the load balancer does health checks against each one of those services to make sure that they're available. If one of them does become unavailable for any reason, say a software upgrade, the AWS load balancer knows that, okay, that machine's offline, we'll use this one only, but the transmitter is completely agnostic to it. So it still thinks that it's perfectly fine by going there because we have these checks and balances and failover mechanisms in place in the cloud. Things to do this in the physical world are fairly difficult and not to mention expensive. So that's part of the demo today, is that we are going to show you how that moves around. We also have Cloudporter 3 and 4 as well. 3 is in the West Coast, outside of Portland, Oregon. And number 4, just for a stress test, is in Sao Paulo, Brazil. Again, not many people are going to want to run their entire infrastructure off the continent, but we wanted to see how bad we could make this thing go. And again, we still ignored Jeff's webinars on IT security, and we're using public internet. Again, it is a stress test. So, and for internet speak, that is 132 millisecond ping time between Sao Paulo, Brazil, and our lab demo setup. And of course, we still have our multicast in the lab, like I mentioned, should the last mile decide to fail. And we are still vulnerable to that to a degree. IT best practices do say you should have a dual homed ISP, multiple ISPs coming from 2 different paths. So, cable modem versus satellite versus fiber. As long as they don't come off the same pole that can be hit by a car, we're okay, which will get you close to that 5 nines number. So if that happens, our local hardware is there to pick up the slack while you figure out what happened to the rest of your infrastructure.
Right, and may I add that it is the same software running in the cloud as on our multicast. So really, from the transmitter's perspective, it doesn't even know whether it is a physical hardware or the cloud feeding it.
Correct.
That is why we chose this platform.
Correct. So if we keep moving here, and you'll see us exactly do this. We're going to start moving it around exactly like our demo that we did with the physical multicast, but instead of using the physical one, we'll save that for the last, but we're gonna move it around the country. We're gonna take our bits on vacation. I can't leave the country, I can't leave the state half the time, but my bits certainly can. So here we are moving along, and this is pre-recorded, guys, just so you know, just in the interest of time. So we do have our transmitter running there. You can see our time alignment is perfect. We're on Cloudporter 1, and we're going to simulate a failure like I mentioned before. And that's where we're going to just simply reboot the virtual machine that this is running on to simulate a failure of that data center. And here you're going to see the red status light there. It lost its link, and the transmitter will wait for itself to figure out, oh wait, that's gone, I've got to go find a new one, and it just did. And so here it comes back again, and it has moved into Cloudporter 2 based on our availability zone and our load balancer. AWS has done its job here. And you can see that based on our metadata there in the bottom right where it says Nautel Cloudporter 2 as well. And no, I haven't seen your monitor, Cloudporter 2, I'm sorry. But again, our level alignment is perfect and well within our target window. And again, we're going to simulate another failure. Say the entire East Coast is offline. So let's reboot that with our load balancer going offline as well. So all three, or those two instances are now down and out for the count right now. So now we're going to physically move this across the country. And again, our transmitter found its way. And we'll wait a second here for it to come through. And the Justin is coming for its time lock. We've already got our metadata there. So you can see the RDS come in there, Cloudporter 3. Our time alignment is perfectly within our window of 68 microseconds. And I don't know, the guys up in Halifax might argue with this transmitter, but they say the seafood's better on the West Coast. But we have now geographically moved our data ingest from the East Coast to the West Coast of the United States. So again, we're going to go into Portland. Portland, you know, the West Coast is having some natural disasters right now. This is entirely possible just the same. You know, AWS is not 100% resilient against Mother Nature. So we're going to reboot that one as well, just to simulate that failure. And again, the transmitter is going to lose its lock by the red light there. And now it's going to go find its next ordered list in its transmitter chain of where its ingest point is, and that is now in Brazil. And again, notice where our FM and RDS are coming from there. It says Cloudporter 4 Brazil. Olá do Brazil, taking my bits on vacation from Cloudporter 4, 4,800 plus miles away from home. And again, our time alignment has stayed perfect. Now we do have a time of flight again, you know, from the input ingest to the transmitter of 132 milliseconds, but our time alignment is staying perfect. And again, we're going to simulate the failure of the cloud. So all four of our Cloudporters have failed. Brazil is offline. And the transmitter is going to say, I've run out of things in my cloud list. I better use the local one here as my backup source. And so it does. And again, it comes in, and our Justin is hunting its time alignment as well as our metadata coming online. And there you go, physical hardware in the Nautel lab. So we have completed the complete circle going all the way around of a fault tolerance system, including stress tests and giving it a little bit more of a worst case scenario. So using the cloud process and having this ability of making the transmitter look for itself, look for its content versus the content being force fed down to the transmitter, we are able to mitigate a lot of this downtime. And yes, in our demonstration here, there is downtime between that. But again, remember, this is a technology demo. You know, we're working on that part as well. Stay tuned.
Yeah, we hope to minimize the downtime for that. It may not be entirely seamless, but there's certainly room for improvement. And in the last demo as well, yes, we rebooted Brazil. However, it could just as well have been your last mile connectivity that could have been the problem as well.
Right. Yep. Any one of those things can fail, and the transmitter is going to go look for what list it has. So what we demonstrated today was how scalable is this system? Well, I moved it literally across continents and replicated it everywhere.
Right.
The cloud availability is
click of the button, and I believe you have to wait until AWS does do the actual copy of the machine, but even that is pretty quick.
correct. And if you have that predefined, it can be a warm standby, a cold standby, or a hot standby. Any one of those systems can work for you. As a lot of people like to say, I can do all my engineering now from bed. A lot of things are done from your phone these days, or your kitchen table, as it were. So the availability and redundancy, again, AWS provides these tools, as does other cloud providers. They're very competitive in this nature. So the load balancing and fault tolerance systems in multiple data centers and availability zones are available in multiple platforms. But again, AWS being the big guy, we went with the big guy just to see how well it worked, and it worked very well.
Now, one question on that, Alex. Somebody had thrown this in, and it fits in here pretty well. If you have an AWS or a virtual server failure, and the system faults over to your next chosen location, if your preferred server comes back online, will it revert automatically, or is that a manual setting?
Currently it's manual, but we are, again, it's a technology demo. That part it has been thought of. It is on our list of things to implement. We just haven't gotten down that far in the list yet.
Very good, thanks.
So it will constantly pull eventually its primary sources versus its backup sources.
Right, and if you're thinking about the load balancer, it will continuously do health checks, so you know that it's back online. However, the concept within the load balancer is that they're all identical. So the idea would be you'd feed them with the same audio content and all that. If you fail over bigger like we have, it could be a completely independent system.
Right, and in traditional broadcast facilities, we have a remote control that alerts us to certain things. One of the things that it doesn't do, however, is tell you that that service is offline. It tells you, your tower lights aren't working, or it tells you your power is low, but it does not tell you, hey, the HD software for some odd reason has stopped responding. AWS has provisions for that because it is just software. It is doing a service check on that health check in the background. If it fails those health checks, your team gets an email. Or some kind of a notification on a dashboard. Everybody knows that there's something wrong and someone has an action to go take a look and see what's going on. So that has, supplanted that part of it, that you can monitor these services, and it doesn't stop with the transmitter. You can even do this to your automation system, provided they have hooks into that world. So we've kind of eliminated that need as well, so you don't have to sit there and constantly babysit it. It's doing it for you. With that, you got the transmitter site IP link reliability. Again, IT best practices are you have multiple dual homed routers on both your content creation side, whether that be the studio or even in my house for that matter. You have two internet providers on one side and two internet providers on the other side. Very unlikely that one or both are going to go down simultaneously if you've done your due diligence, as don't order two cable modems from the same provider, for instance. You want to make sure that they are completely redundant. Do your homework on your internet providers. The greater internet itself is self-healing. It won't fail. Short of the West Coast burning down and physically damaging the data centers, there's no technology in the world that can help Mother Nature in that respect. But we've tried to eliminate a lot of that, and we approach that 5 nines, if not 6 nines, by this approach. Even AWS quotes those numbers for how we followed their best practices and their blogs on how to practically set this up to make sure that it's always there. And again, the IT security side of it, cloud VPNs, AWS, giving Jeff back his crown. AWS realizes that it's the cutting edge technology in their world. We extend to ours, so I can make all of these VPSs look like they're sitting on my local corporate network without having to do anything in between. So it's not traversing the public internet. It's highly secure in that respect, and you can get brand name VPSs that do that for you from like Fortinet or Cisco or Palo Alto, some very big names in that world, to bring that infrastructure into your physical environment without having to pay for power, cooling, floor space. It's all over there, or over there, or over there. So that is what we're working with here. And then again, you know, you want to make sure that your transmitter is airing your content, not anybody else's. So we also are looking at putting in public-private key SSL to make sure that the transmitter is talking to the correct unit, and nothing can break that. You have that key, not us. So we can ensure that the integrity of the content is where it's supposed to be coming from. And as such, you know, as everybody else has touched on, our workflow flexibility, we're all working from home or our offices in certain cases if we have to, but we can maintain a safe distance. Let's use example of the West Coast fires right now, where you need to get that content to, in an emergency situation, to the listenership, but you got to do it from a safe distance. So while you're traveling away from the fires, keeping your family safe, for some odd reason, radio guys have this moral obligation to make sure everybody else is just as safe. It's what we have and what we've traditionally done. So you want to make sure you're safe, you and yours are safe, but you also want to provide that information to your listeners to make sure that they can get out safely just the same. And you don't have to rely on the radio station that is in downtown that's half burnt down. You know, you can move this around and you can be flexible on how that works. Or in a pandemic situation, we can do it all from home. You kind of wrote a story earlier this year of how fast we could scramble a studio into a guy's kitchen table. Those kinds of situations shows you how flexible this would have been had this technology been employed from the get-go instead of, and I'm pretty sure a lot of big guys have used this exact thing. They turn to the cloud solutions to figure out how to make that happen without capital investment, wait times, lead times of hardware availability, building out an infrastructure in the physical plant. It was already here. They just they pivoted it on a dime and said, put that here.
Right.
So we have this workflow flexibility on both sides now, whether it be the studio or the transmitter.
Right. Our focus has mostly been on the transmitter side now. So, you know, stay tuned for more updates as we look at further things like how to integrate with other cloud services or play out or, you know, Exactly. There's certainly, this is only the tip of the iceberg. We're just trying to show the industry a technology direction. There's more to come.
Yes.
And I mean, really, I think, you know, at this point, what we're bringing to the table here is, you know, new options of setting up a radio station. You know, certainly we're not saying that today's topologies are no longer valid. No, they certainly are. There's nothing wrong with following the guidelines, the ones published by the NRSC, keeping your importer exporter at the site, GPS locking everything, using your off-air, what we call reactive receivers to maintain your diversity delay. There's nothing wrong with that as long as it's set up correctly. However, what we're demonstrating today is that really we're becoming location agnostic. And it's a bit of a lofty word, but the idea is that it doesn't matter where the importer exporter and the audio processing sit anymore. And we're able to accomplish that with our software implementation. We've talked at length at our resilient backup options with the HD multi-connects. But the one thing to think about here is we demonstrate today how the cloud is your main content source and how we fail back to local equipment. Well, we could also envision a future where you may still run on the transfer site equipment 24/7, but the cloud may supplement content. So that's still yet another use case we can look, or a new topology we can look at as well. But all this is made possible by removing hardware dependency, removing the need for specific audio capture cards, removing the need for GPS disciplining, and moving into virtual environments. That's really the stepping stone that we're bringing here. And it opens up two options for you. You can either host it in your own data center, if you have the IT expertise and you know, if you have the resources to do so, that's certainly an option. The other option is to use AWS or another cloud service provider who will do the IT heavy lifting for you. So, both of these options are certainly future options here. And
that kind of, before you
ahead.
get going too far, that kind of ties into something we'd been discussing a little earlier with some of the high-speed satellite delivered internet capabilities or network capabilities.
Correct.
So, you're no longer restricted by not being able to get internet at your transmitter site.
Right. Yeah. I mean, if anybody's following the buzz right now with the space race of the modern era, is Amazon and SpaceX are trying to deploy a space-bound internet service provider worldwide, which it's not public yet, but some of the beta trials that they have shown publicly is that it's more than capable of utilization for the broadcaster with the amount of throughput and latency that it's providing on mountaintops at this point. Where inaccessible sites where dragging fiber up the mountain isn't an option, or even cellular sometimes isn't an option.
Right. And whether that becomes your main way of delivery or becomes a second ISP option, both of those options are available.
Correct.
So you have very exciting times. One slide that we keep on coming back with is, this idea, can we centralize the entire HD radio air chain? And even though we haven't shown that exactly in this configuration today, I think we can show yes, based on premise that we've shown you many different air chains all across the globe, taking them on vacation. And we showed you they would all, connect to a single transmitter. But you can certainly see in reality, it would be more that many air chains connecting to many transmitters. But you can kind of see that, we're showing the same concept here. Location no longer matters. So it makes sense to centralize, or if it makes sense to manage things more in a uniform environment, you may want to centralize essentially your studio equipment. So that is now a possibility. It's not the only way to do it, but it certainly opens up new doors for you.
Right. One of the big things I want to touch on that is actually, the things that keep us all up awake at night. The 3 a.m. phone calls of, oh, my audio processor power supply failed, or the automation rebooted, things like that. Just general hardware failure at all is a thing of the past in this world, because it is software. The hardware is no longer your problem. That's your cloud providers. If you do your own on-premises, that's your IT department, but your IT department has the expertise that, in a virtualized environment, you don't run it on just one machine, you have 3 or 4. And they're set up for high availability, so that if one fails, the other one takes over, that cluster, and so on and so forth. That's the competency that they have to bring to the table for us to utilize.
Right. So yeah, in summary, the cloud offers many opportunities, from availability, resiliency, flexibility, and more to come on that. How to manage it. AWS made it very easy to manage your equipment. You can do it from home and anywheres. Shown how easy it is to deploy, how easy it is to clone, and it will open up more flexible workflows. All of this is made possible by having this FM HD time lock that eliminated that tight 68 microsecond specification that we need to meet. Without that, it would be very difficult to achieve what we're showing today. It now opens up the potential to put your importer-exporter at the studio, the transmitter, or local or cloud-based data centers. But we want to highlight that today, this is a technology demo that points us in a certain technology direction. We're not announcing specific products at this point or availability. We are looking towards beta trials, see if we can do some limited tests with that, iron out the kinks and reliability and security and all those sort of things. We'll get that all solid, and we're also hoping to drive standards to include this new method, which will take some time as well. But in the meantime, we will lead with what our implementation is, and we will follow what the standard bodies come up with. And that essentially brings us to the end of our presentation. And back to you.
Now we have questions.
Oh, and lots of them.
Oh, I'm sure.
Oh, lots of them. Yeah. So Mark Wachowski asked a really good question. He's got a separate importer exporter with HD and analog processors at the studio, or HD processing at studio, analog processing at the transmitter. So he's running an NV10 with legacy importer exporter. How adaptable would a solution like this be to legacy equipment?
Well, that's a very good point here. I mean, certainly we're showing new technology, new advancements. So certainly it is future looking. But in the end, if you want to consolidate your air chain into a centralized studio, well, if it's a fleet upgrade, you need to be able to handle new equipment as well as legacy equipment. So that is a very, very pertinent question. Now, certainly, we would have to look at the specific transmitter model as to whether we can bring the new features into that particular model. But if so, then it would be a seamless fit. But the other thing to mention here is because we are not proposing a completely radical new way of feeding our transmitters, we're building on made-for-radio standards. And that was the key in our first two presentations, is that we're building on made-for-radio standards. We can still address legacy equipment in that way. We're still using essentially the E2X protocol for the HD delivery as always, so that we can feed, even all the way back to a 2005-6 vintage M50 exciter could be fed that way. The caveat with it, of course, is that with legacy equipment, we can't guarantee the time alignment. So you would still need to have an off-air receiver and keep an eye on that. That is something that would only be for new equipment. However, using that, a time receiver, and a Telos MPX node to feed your FM, we believe that we could feed a diverse fleet of transmitters with the same approach. But new equipment will simply be more streamlined.
Okay, good. Sorry, I was trying to type and think all at the same time. That's just never a good combination for me. Now, Rich Hahn had also asked if we had any guesstimates on how far we were being able, or how far we were from stations being able to run something like this. I mean, as you said, it's a tech demo right now, but what are the odds of being able to, I guess, productize it to make it commercial sounding? But what's a timeline look like in your mind in a perfect world?
Well, we are looking for essentially suitable beta testing in Q4 by the end of the year, sort of thing. Now, if you are interested in being part of such a program, let us know. We can't make any guarantees as to how many we can select for this program. We'll have to limit it to a set number of systems. But then as we get more developed, it will grow. So yes, we're hoping to look for beta customers or beta trials soon. Before we do that, we'll actually do some alpha trials first and put it on the air to make sure that we're comfortable with what we can do.
You've got one or two signed up already in the questions, Mark. So yeah, right. We'll make sure to get you that info. Eric's case asked, is the program source material being transferred from the studio to the AWS server via an iPort or Zip1 codec? How are you moving the audio around?
Several different ways. As a matter of fact, we wanted to, again, it was more of a stress test and a technology demo of let's see where the problem exists, and we honestly didn't find one. So the main audio, for instance, was using a FLAC stream, utilizing the stream receiver inside the Enterprise 9S, as well as the other ones, taking inputs from Radio Jar, which provides an MP3 stream out. And then here at my house, I have a Livewire network with random playlists just running in the background that we were encoding and sending up there as well. Telos does have some features that are forthcoming that I'm aware of that they're working on to address this exact thing for their Infinity product. Which we've looked at it and said this would be perfect for our system as well. So we've kind of said, okay, let's go to the drawing board there, and they're hard at work at coming up with this. But yes, you could use an iPort if it does talk Livewire in the cloud, There are certain limitations thereof, and I know that Telos Alliance is working diligently in doing that in their environments just as much. So the input is right now a streaming of some kind, whether it be FLAC, MP3, AAC, or MP3, have all the above for now in this
Okay.
in our technology demo.
Very good. And I've just gotten a note from Ed, our disembodied voice, who makes everything function in these things, that the survey that folks are going to get after the webinar will include the option for them to volunteer for beta testing. So by all means, if you want to be a guinea pig, sign on the dotted line. We're happy to have you. Now, Franklin Oklu had asked how the African continent would fit into these features, and I guess the short answer is if you've got internet, this can work. Is that about right?
Yeah, it's exactly that. You have a transmitter. If the HD radio is available in that country and licensed for authorization use, turn it on. This will work.
Now, Jeff Kofsky's asked a few questions that have been really informative. So, Jeff, I want to give you a special shout out and a thank you. And he asks here, with the Multicast Plus at the transmitter, could you talk over with a studio, or could you take over with the studio at the transmitter? So say you had a studio emergency, you could almost, if you're virtualizing everything, you got, again, flexibility, right?
Absolutely.
And it's really up to you as to how much you will, back up as such at the transfer site. Maybe all you want to do is just back up the FM. Well, that's an option. Maybe all you do is back up FM and HD1, HD1, 2, 3. I mean, essentially, you will have a microphone input at the transfer site if you wanted to turn that into an emergency studio.
Okay, and this kind of ties into it. Rick Jesse asked about a direct ubiquity type link to the transmitter. So connecting direct to the transmitter without any intermediate hardware. No reason you couldn't do that.
Absolutely. The perfect point that Marty had made earlier is that bits are bits, IP is IP. What we're shoving down the line on either direction is still just IP. So any means of IP transport is what is suitable to move this data.
Right. For the initial beta test, we are going to require an HD multicast at the site. So that will be the only piece of equipment in between for now. But that would be for initial deployment. Long term won't be required anymore.
Yep.
Excellent. All right. Well, on that note, gentlemen, we are running pretty close to 10 minutes over time and apparently the young fellow just got home from school. I hear the dogs going upstairs. Anyway, on that note, I want to thank you very much. Special thanks to Marty Sachs, EVP of Sales Support and Marketing for Telos Alliance. To Rick Greenhut. Rick, are you still here? I don't know if Rick's still here or not, but definitely thanks for his insight.
I am here. Rick. Thank you.
Awesome. Great to have you. And Philip and Alex, again, thanks for taking some time with us. And on that note, folks, thank you very much. Have a wonderful day.
Thank you.
All right. Good.